Now there are several ways to do this problem, the proper systematic way and the divisibility way. I'm going to do the divisibility way first because that's faster over here. 4-digit number n, we have a 4-digit number n such that when divided by 3, 5, 6, 9, you're getting remainder 1, 3, 4, 7 respectively. What is the smallest such value of n? So since they are asking for the smallest value, I have to start with the smallest value. So this is the smallest value, 1068. So when I'm dividing by 3, I'm supposed to get remainder 1. So let's see what I'll get remainder when I divide by 3. See, you know the divisibility rule of 3, right? Divisibility rule of 3, there are multiple ways. One way is that adding the digits. Adding the digits and then getting that value and checking if that is divisible by 3. This is divisible. This number is entirely divisible. You will not get remainder as 1. So that is not the answer. Okay. And one more thing is that whatever value you find here, okay, if you divide that, then the remainder you will be finding, will be the same remainder when you divide this number by 3 also. There is another one method also that I will see eventually. So this is not the answer because that's getting divisible by 3. If you check the next greatest value, so next greatest value is 1072. 1072 divided by 3. If you check by this method, 1 plus 7 plus 2, you will get 10. So I want to find the remainder. Just take 10 divided by 3. 3 times 9. 9. Remainder is 1. So here the remainder, this value divided by 3, remainder will be 1 itself. Same as with this value. Okay. So here also remainder is going to be 1. Now again, there is another one more method of finding this divisibility, this remainder and checking with this divisibility rule. That's much more easier. But you know, I'll tell you that in a separate content. Let it be like this. Okay. Of course, yeah, if you want that, you have to subscribe. That's the only way you will find that. I wanted to tell you now, but the question will become too long. Anyway, the number is divisible, not divisible. We are getting remainder 1. So that is okay. Now let's see remainder with 5. They are saying that when you're dividing by 5, you should get remainder 3. 1072. See, the divisibility rule of 5 is checking the last number. If that number is divisible by 5 or not, or if that number is 5 or 0. You can also use that condition for finding the remainder. What to do? Take the 2, divide by 5, 0 times 0, remainder is 2. So 1072 divided by 5, you will also get the remainder 2. So the question is saying that you should get remainder 3. You are getting remainder 2. So that's not the answer. Next. So you will go to the next value. Next greatest, 1078. Again, recheck all the stuffs. 1078 divided by 3. Let's see what the remainder is. Remainder will become 1. Okay, so that is fine. If you check the remainder with 5, 8 divided by 5, 1 times 5, remainder is 3. That is also masked. Now, when you're dividing by 6, you should get the remainder of 4. Remaining by 6, you should get the remainder of 4. 1078. You can directly try to divide, or you can use a remainder theorem. If I cancel 2, or if I divide 2 on both sides, I will get 1078 divided by 2 is 539 whole divided by 3. Okay. Now if I check the divisibility by 3, I'll find the remainder is going to be 2 when I'm dividing by 3. But since I have already eliminated 2, I have to multiply that thing value back. So remainder is gonna be 4. So that is also correct. You can simply check the divisibility by 4 by dividing this thing. This is a trick which I used from remainder theorem. Okay. Again, we don't have enough time in this video. I'll say that as a separate thing. You can simply divide this value by 6 and see what the remainder is getting. It's again 4. That is also fine. Now 9. 1078. 9's divisibility rule was 1 plus 0 plus 7 plus 9. 1 plus 0 plus 7 plus 9. That is 17. That should be divisible by 9. Again, you can also use the same divisibility rule to find the remainder. One time you will find the balance is 8, right? Yes. So the remainder should be 8. What's the remainder which you are getting? Oh, they are getting remainder 7. So that's not okay. Wait, my mistake. This is not 9. We are supposed to check with the value 1078. 1078. Yeah, now I can check. So this is gonna be 17. No, yeah, 1 plus 8 plus 7, 16. Therefore 16 divided by 9, 1 time 9, balance is 7. Yeah, so this is not 7, it is 7. So 107, when you do 1078, when you divide it by 9, you will getting remainder 7 also. So this is the answer. The smallest values is satisfy this. Now this is the shortest way to do this problem. But if you want the proper method, I'll show you the proper method also. See, let's take the numbers 1, 3, 4 and 7. 1, 3, hey, 1 is, that's a reminders. What's the numbers? 3, 5, 6 and 9. 3, 5, 6 and 9. The first thing is that we are supposed to get some reminders while dividing some random number. Before actually getting reminder, let's try to find the number which when divided by these numbers, it should be perfectly divisible. Such a number is known as LCM of this number, the smallest such number, or common multiple. So this is 3, this is 5, this is 2 into 3, this is 3 square. If you find the LCM of these numbers, you will be finding 2, take as it is, 3, take the highest power. No, here also 3 is there, but that doesn't matter. Take the highest power, 5. So if you do it, you will find 90. So basically 90 is a number which is divisible by all this given number. Now, if you add any value which is less than all of this given number, that means 1 or 2. If I add that value to this 90, that is 91 or 92. When I'm dividing this 90 by any of this given number, take randomly, you can check it yourself. Let's take 5. If I'm dividing 5, this is perfectly divisible. The remainder will be 0. But if I'm dividing by 5, this number, that is LCM plus 1. Here the remainder will be 1. If I divide this by 5, the remainder here, LCM plus 2, I am going to get remainder 2. Of course, you have to take a number which is less than the smallest value, okay? Otherwise, this method will become wrong. So, the condition which I just told you is that LCM plus a remainder which is smaller than the smallest value, when divided by this given number, you will get the remainder R itself. It doesn't stop there. You can even say that LCM into X, where X is a natural number. LCM into any natural number plus R. When divided by this given number, the remainder is going to be that added R. Why? The reason is that these numbers have lot of common multiples. The lowest one is 90. If you want to find the other common multiples, simply you have to take 90 into 1, 90 into 2, 90 into 3, 90 into 4. Basically 90 into X or LCM into X. So all these numbers are divisible by all of these given numbers. If you add a remainder to them, let's say 2, the new number which you are gonna get, that when divided by these given numbers, you will get remainder as 2, whatever you added. Okay, so that is the condition. Now, but the question here is that we have different reminders. We don't have a same reminder. That is a place where a negative remainder concept comes in. That basically means if you check these values, they are not random values. We have the numbers 3, 5, 6 and 9. When you are dividing that numbers, you are getting 1, 3, 4, 7 as reminders. 1, 3, 4, 7 as reminders. These values are not random. Why? If you check 3 minus 1 is 2, 5 minus 3 is 2, 6 minus 4 is 2, 9 minus 7 is also 2. So what is basically happening is that this have some basic conditions of divisions, okay? It's like just one question problem, like just one explanation in this question will not satisfy this the depth of understanding which you need, but I'm still going to try. This need more explanation, a lot more explanation. So when I told you that 90, which is the LCM of this number, that is divisible by all these numbers, let's say 5. If I add plus 1, then I will get the remainder. I will get the remainder 1. Similarly, if I take this 90, I'll take minus 1. Then I'm going to get 89 by 5. The remainder for this thing, interestingly, the remainder for this thing will be, see, this one number was divisible. I'm minusing 1. If you check, the remainder will be 4. The other way to find that is that I'm minusing 1 from this divisible value. So the remainder will be 5 minus 1 or 4. Once more. 90 minus 2. 90 is divisible by 5. I'm minusing 2 from this. The remainder for this value, that is 88 by 5. It will be 5 minus 2. 3. If you check it, you will find the remainder is 3. That basically means we know that a number, the LCM of these given numbers are 90. We also know that 90 into x is a natural number, will be divisible by these numbers. If you add any remainder, then this number, when divided by these numbers, you will get the remainder r. Interestingly, the common remainder which we are talking about in these cases, okay, they are 1, 3, 4, 7. They are not random numbers. You can get that values if the remainder was minus 2. That means if I have a 90x and if I'm doing minus 2 from it, if, see, this should be the remainder, right? So to get that remainder, what should I do? Divisor minus 2. Divisor is 3. 3 minus 2. So 3 minus 2, remainder will be 1. 5, divisor minus 2, remainder will be 3. 6 minus 2, remainder will be 4. 9 minus 2, remainder will be 7. So this is the condition. We'll go through more depth of this when I am going through the topics of LCM and divisibility and other stuffs. Anyway, the thing which we just found is that 90x minus 2, this is the form of the number which we are searching for. Now the question is basically asking you to find the smallest 4-digit number which satisfies this condition. First of all, the smallest 4-digit number is nothing other than 1000. I'll take 1000 and I'll divide that with 90. I'll divide that with 90. 1 time 90, balance is 10. Another 1 time 90, balance is 10. So we know that dividend is equal to divisor into quotient plus r. I am taking 1000 and dividing with 90. I got quotient 11 and remainder as 10. So 1000 minus 10, taking this plus 10 to other side, 90 into 11 or 990. 990 is a number which is divisible by 90. Okay, but I want it to be 4-digit number, or 990 is a multiple of 90, 11th multiple. If I want to find the next multiple, like 4th digit number which is divisible by 90, I simply have to add 90 to both sides. I will get 990 plus 91, 10. 80 will be 90 into 12, 11 times and one more time 12. So this is the next number which is divisible, or the smallest 4-digit number which is divisible by 90. So 90x or 1080 is the smallest 4-digit number, a multiple of 90. Minusing 2 from it, you will get 1078, which is our answer. Again, you don't worry about this part. This way of solving this question, it needs more understanding. Okay, first thing we have to know is divisibility. We have to know divisibility in a depth. Then we have to learn about multiples, how to find different multiples. Then we have to find the n-digit greatest and smallest numbers which are divisible. Then we have to learn LCM. Then we have to learn reminders. So all these topics are there. It will take some time, but not hard. Okay, it's like it's just need some more time. That's it. So that's how you solve this problem. Answer is anyways.